All right, we'll continue uh, from mutable, immutable. There's two things we have seen, right, in Scala. So we are in basic of a Scala, currently learning the syntax. So this is the cell. I can go back to my Scala cell downloads, setup Scala. Bin is Scala. Now, mutable, immutable already we know. Just quickly repeat. Val is for immutable and var is for mutable. So if you make anything as var, you can change it. If you can make anything as well, you cannot change it. Now here we can see some other application. Okay, we can use like this. Well, I'll tell you a few short concept in Scala. Well, x is equal to 1 to 10, right? Where x is equal to 1 to 10. So I can write like this. If I want to create a range from 1, comma 2, 3, 4, 5, 6 till 10, right? So this is like a range creating. You'll see it here, 1 to 10, I said, and it has given me a range which is 1, 2, 3, 4, 5 to 10, all the numbers. Now, range is by default, if you see, this range is created. If you see this range is, one second, this range is immutable, right? By default, this range is immutable, and this comes as an immutable property only, which means once this is defined, what does this mean actually? So immutable has two internal concept. First, some immutable says you cannot increase or as an grow or shrink the size. Okay, so immutable means the first logic I'm saying, you cannot grow. Let me write it here. You cannot grow or shrink the size once it's defined. Once it's defined. What do we understand by the point number 1? You cannot grow or shrink the size. So total 1 to 10 is the size here we have, and you cannot make it 11 from 10, and you can't even make it 9 also. So that's what grow and shrink means. 11 and 9 you cannot make. However, you can change their internal element. So index wise, if I read, I can read it as always your indexing start from 0. So I can make this point. This is well easy and known to us, but important. Always index start from 0. Do not read from 1 because you'll make a mistake then. Third point, some immutable says you cannot even increase or shrink once it is defined. Some says this is applicable for all, by the way, you can't grow or shrink. Some immutable says you can change, however, you may change existing index value, or I'll directly say you may change index value, which means you can change this 1 to 10, you can change this 3 to 30, you can change this 4 to 0, but you are changing the index which are already present. You cannot add one more index here, and you cannot delete any element from this existing list. That's what immutable is. So this third property is not applied with all sort of immutable. This is only applied with array and some other immutable concept, which says you may change the index value, but size you cannot change. So these 3 points will remember. These are first and threes somehow confusing, but I think this first you can understand. This is not applicable anywhere in the immutable property of range. This third we can apply somewhere, and if you have a confusion, no worries, you can start checking it. Can I change this value from 1 to 10? And if you have that question, we'll try to do that. How can I access any index? I said always start from 0. So can I write 0? So when I type 0, I can see this one. Can I type 1? So this is 2, second index. Similarly, if you type x10, you will get exception, index out of bound exception. And why you are getting an exception? Because total number element, if I read, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. My total index is till 9, and I'm giving here 10. Right? So whatever you write in the bracket, this is index. We use this bracket for index. Always remember this index also. It says me index out of bound exception. There is no index which are having any size as 10. Okay. So if I check till 9, I can see last element, which is 10th. I want to change this value from 9 to 100. Sorry, 10 to 100. So ninth index, which is this index, and I want to change it from 10 to 100. Okay, now since I want to change it from 10 to 100, what it says me, you read the error, and maybe the best practice I can say, you should write this error or exception in your some notebook. So this is a question actually they ask in production while working with Scala, with Spark. What errors did you get? So you can use those errors. Anyway, we'll see that, but this is a good practice. If you're having time and getting this exception, please note this exceptions down in the notebook. What it says, value update is not a member of Scala collection immutable range inclusive, which means this is a package which does not support any function on any operand which are type of update. So immutable does not support update. That's why you're getting the error. So one thing is clear. I cannot even change their element. So you can say here range is immutable. Range is immutable. So size we can't shrink and increase, that's for sure. Even I can't change even I can't change element also once it is defined. So once it is defined, it's fixed for the entire scope. That's what range is saying. Now, can I uh, type 1 to 10? There's one more thing, okay? So 1 to 10, and let me take this as x1. This is 1 until 10. Now, what do we mean by 1 until 10? 1 until 10 means last number excluded. This last is excluded. We have 1 to 9. Okay, so until, as we know from English word, this is the same thing. Until 10 does not include the last element. Take only till 9. The same concept to access this value. If I want to see the complete, I can say x1. Then I'll see the whole range. Okay. Similarly, you can use x. So y is equal to 1 to 5, or let me take 10 only. 1 to 10 by 2. So this is like a step size. It is creating 1 to 10 number. Okay, it is creating exactly same number, which is this 1 to 10. And when you're saying by 2, so what they will do, it will read first element by 2. It will skip this one. So including this and this, it will skip this one and print you this. Then again it will include this and this one and skip the fourth one and give you print 5. Again it will include this and this one and skip sixth and give you 7. Skip 7 and 8, give you 9. Skip, so you'll get total value 1, 3, 7, 9. That's what it means 2. Give me every step after 2. So this is like a step size. Okay, we read this answer as a step size answer. So hope this is clear. 1 to 10 by 2. We can use this kind of shorthand in a Scala. Okay, very easy, very simple. After that, can I play with some string thing? Well, s is equal to Scala, and well, s1 is equal to Spark. Okay, now I want to concatenate. I want to add, well, s2 is equal to s plus s1. This is what is the concatenation. Okay, can I apply a method of concat? I'll be getting the same answer, I believe. S dot s2 recursive value s2 needs a type. Okay, I'm sorry, this should be s1. So this is your concatenation method. You can apply concat or you can directly use plus. Okay, similarly you can use, well, m is equal to 2 plus 3. So this output will store. You can do any kind of binary operation like addition, subtraction, division, multiplication. Okay. Now this is about your functions, operators, what values. You can even define your Boolean also. Okay. So you can say, or you can compare it also. Okay. You can compare like S1 is equal to S2. This will give you answer in Boolean. So we are saying S1 is Spark. I'm sorry. S1 is, yeah, S1 is Spark and S2 is Scala and Spark. Is this similar? Obviously, we'll get answer as false. So I do first S1 is equal to S2. Okay. Reassignment to well is not allowed because this is all well. I'll change this to well S1 again and try to write the same thing in bracket but all in uppercase, Scala and Spark. Now can I write S1 is equal to S2? I'll get an answer as false, but I can apply some sort of functions here. I can say S1 dot 2, let me apply uppercase. 2 uppercase is equal to S2 dot uppercase. This time it should give me answer as true because 2 uppercase, if I'm applying this value of S1, which is Scala Spark, this is uppercase anyway, and I'm applying this on S2. So S2 output is this Scala Spark. If you apply 2 uppercase on this answer, you will see all the letter in uppercase. And since both are uppercase, they are matching and giving you answer as true. This is resulting you answer in Boolean. I can check this math also. I can say, well, A is equal to 10 and we should write this as recommended. Well, B is 20. This is also an integer. And I can say A is greater than B, or I can say A is less than equal to B. I'm sorry, this equal to will go this side. S is less than equal to B. This is true. I can say A is equal to B. So all this comparison operator, this is a comparison operator, right? Comparison operator we have seen. Then assignment operator, we know assignment operator is like this. A is equal to 10 you said, and then again you're saying A plus is equal to 2. So this time, one second, what is the answer of A? I made that well as, let me try to make this as where. Okay, now if I type A, I'll get answer is 12. Why? Because A is 10, and this is as similar as this line is as similar as A is equal to A plus 2. If you read this line and if you read this line, both are same. So this is good if you do not understand this kind of assignment. A is equal to A plus 2. A value is already 10 plus 2, and this is what I'm getting as A output. So we can apply not just addition, we can apply A is into is equal to A, minus is equal to A, divide is equal to A, modulus is equal to. We can apply any sort of binary operations. So comparison is okay. binary is okay, how we're using this binary operation. Now we'll see some logical operations. Okay, so logical operations works this way. Let's say I have first I will create two boolean. If I want to assign anything as boolean 1 and 2, I can say b1, and this is true. I think p is small. Yeah, so automatically it is taking this as a boolean. Okay, similarly if you say this is 2, which is false, so this boolean is false. b1 is true, b2 is false. Okay, now you have defined this directly. You can, if you're comparing anything, you're getting answer in this form only, true and false boolean. Can I do logical operation? I was saying, right? Logical operation, we have not equal to operator, and operator, and or operator. So I'll first try to use my, let me say A, and what is B. So here I want to apply one logical. I'll say is A is greater than, is greater than. So I'll apply some kind of if condition here. A is greater than B and A is less than equal to B. So give me 1, else 0. So I'm using here a logical operator. This is AND operator. And what is the AND operator, by the way? There are two rules. So let me write it as a logical operator. Logical operator. Here we have first operator as AND operator, second operator as OR operator, and third operator as NOT operator. AND operator, both the condition true, then true. Both condition true, then your output is true. Remember this, both the condition has to be true, but for OR, out of two condition, any one condition is true. Any one condition should be true, then this is true. So it first check the first condition. If first condition is true, it does not even check the second condition. It directly gives the answer is true. If first condition is not true, then it checks the second. If second is true, it gives you true. If both the condition is giving you false, then you get false. Not is just opposite of anything. Not is like this, exclamation mark. If you say not true is false. If you say not false, it's true, like that. So not operator, we'll see. This is also very useful, very handy when we apply this sort of logic. So why you're getting answer is 0 for this if else condition. And this is a conditional expression, and we're going to see all these conditional expressions. So I'm using if A less than B. Okay, if A less than B, A value is 12. And conditional expression is very important to write within our function, within our block, within our classes, within our objects. So we'll be using this a lot, especially in a imperative programming. So we have two types of programming: descriptive programming and imperative programming. So imperative is the one where you apply all this loop, all this expressions, all the concept of oops. There we say it's an imperative programming style. So 12 is less than 20. This condition is false. And as soon as this condition is false, anyway your answer will be false, which means it will go to else loop, because this AND operator is saying both condition should be true, must be true. This is false, this is true, because 12 is less than equal to 20. This condition is true, but since one condition is failing, here it is going to else loop. If it is true, let me change the operator. Let me say this is OR operator. then I will get answer as, this is the sign for OR operator, then you will get answer as 1. So what we are saying, if this condition is true, anyway, if condition I will take it separately, I will explain this if else condition once again. Currently we're just learning the syntax, how you can write the syntax in IntelliJ. This is not, this is end sign. You are saying first condition, second condition. So whatever you are writing within the bracket, this is your condition. If this condition is true, then it will return 1. If this condition is not true, then we know, as we say, else this will happen. So the same thing, else this will print. Since first condition is not right, it directly move to the else part. If I'm using OR operator, I know the answer, this will give me as 1. And why it is giving me as 1? Because one condition is true. Because one condition is true. Okay, this condition is true here. Similarly, can you apply not operator? You can say, you can directly apply without using if else condition, a not equal to b. Yes, because 12 is not equal to 20. So I'll get answer as true. This is your logical operator. Then membership operator we have seen. What is the membership operator? That 2 until whatever you have used, 1 to 10, 1 until 10, all these are membership operators. Now, can we solve any body or any block expression? So here I'll say, well, BLO is equal to, in this parenthesis, so I'm creating one variable as BLO, and in this parenthesis, I'll be writing some logic. I'll say, well, so A and B is already known to us, but I will again try to define this, where A is equal to 20 and B is equal to 30. So what is B minus A? Okay, let me change one thing to 30. Then I'll see what is B minus A. So in just single line, actually I have proved that the answer is 10 in just single line using this code. We have proved that this BLO is integer. This BLO belongs to integer data type. The output is 10 because that's what you'll get, 30 minus 20. If I write the same code, if I want to print this 10 in Java, I'll have to write at least 10 line of code. Okay, and I have tried this, proving how can I write the same thing in Java and then get this answer. So what we're doing here, we have given, let's read this whole signature. This is the well immutable. This is my variable name BLO. Then you within the variable body, this I can read as a variable body. So in variable body, I have defined first variable which is A, 20, second variable which is B, separator terminating them using the semicolon, and after that I'm saying B minus A, which means when you say B minus A, you're saying 30 minus 20. So no need to write return in other thing. Return is optional. I think already I explained in the first class, which was day before yesterday. Return function will be only using when our function are recursive. A function can call itself like Fibonacci, factorial. So when this is recursive, then, however, this is not function, this is just a variable. So in this variable, I've given this, whatever is the output of this expression, the same data type will be assigned to this. So this is coming as 10, which is an integer, and that's why the integer defined to BLO. So remember, when you're solving any block, okay, their expression or their function body, whatever output you are receiving, this data type is your variable data type. Okay, because this is how it works. But this is just a block. Can I try some other approach? Can I use where? So here I'll say where condition is equal to I'm using if loop again. Condition is equal to if, and here I'll say BLO is less than, greater than 9, and BLO itself is less than 25. Then give me 1 else 0. We already seen this. So I'm trying to check this output of BLO, which is coming as 10. And here I'm checking this condition. So always when you see if else loop, try to fit your variable values in this expression. So expressions will fit in this case. First value check. BLO value is 10. Okay, this is my value of BLO 10. Here I'll say if 10 is greater than, the sign is greater than 9, which is true. Yes, 10 is strictly greater than 9, and let me write in English, and this BLO, which is 10, is less than 25. Yes, this condition is also true. Since both the condition is true, we get again answer as 1. Now I'll give a twist here. I'll change my one parameter. So how I'll be changing my parameter here, I'll say if this is there, then return me as 1, and then if this is there, return me as 0. Now answer logic wise, this should give me the same answer as 1, but earlier you see data type for con. Okay, earlier you see data type. So let me do this first. If this is I'm testing for 1, I'm getting 1 as output because both the condition is true, and con is a variable which has a data type of integer because 1 belongs to integer. Now the question is, if I change this 1 to string 1, then if you're thinking this is a string type now, okay, so yes, you're true that 1 is a string type and 0 is an integer type. Now here is a one of error, compilation error, because two different data type is there in your return statement. Okay, now if you check this value, this is a string. If you check this value, this is integer. And what is Scala says, when there are mixed data type, not necessary always has to be string and integer. It can be long, double, integer, float, integer string, which we are saying it, float string, any combination with a two different family. Because integer is a number family, string is a sequence of character family. Both are different family, and hence their super type. Whenever you have this two mixed, their super type is any. This is like a rescue for you. Okay, this is literally like rescue. I have used in many real-time applications. Whenever my program is stucking, unable to understand that, I used to apply any, but from the optimization side, this is not so cool adjustment, because any, if you're typing any, will be a super type, and always any super type will have a more range than this two data type, string and integer. If I'm collecting this two ranges, then I'm getting any. So anytime this size is bigger than this two sizes. Okay, so when you're getting error, then only try to apply this any. This is, let me write it, this is a super type. Super type means if you are unable to define any data type while creating a function, you're getting some error, you can check with any should work there, but use carefully because the size of any is anytime larger than any other data type. That's what we're calling it's a super type. Okay, so in nutshell, I can say if there are two different data type which are mixing to each other, a different family, we can say they're any. When I say different family, do not consider long and integer from different family. Their range is different only. This takes total range of 10. This takes total range of 9. So 9 is a digit. We can have any value in this 9 digit. So there is one range defined for 5 plus 4, 9. There's one range defined, I do not remember, that's -2 for something. Okay, we can Google it up and we can see this range for integer and long. So range is different thing, family is different thing. Remember this too. So if I type now, you'll see the data type for con is coming as any. Okay, so hopefully this any is clear now. Any is uh, super type. Then where op1 operation 1, and I want to create some lazy thing here. Okay, so lazy evaluations will check. Actually, lazy is one of the terrific concept in all the programming languages nowadays. In fact, to speed up your website performance, to perform upscaling, downscaling on your server, everywhere we are using this lazy. Lazy is in fact giving us the serverless architecture using lambda functions and other thing. So what this lazy means, we'll see first. Currently, what is happening, let's say my if I take example of website, okay, let's say if you go to website, so we have applied this concept in this website. I'll take this indirect example. I'll go to this is streaming site. Here I will write potic.com and try to open this site. So it's a new incognito mode, caching the data first. One second, actually this is connected to my phone, that's why speed is less. Open this site, okay? If I open this site using this DNS, which is poverty.com, or some here IP address. This is binded with some IP address. Okay, so let's not go to network area. Let's understand the concept of lazy. Now here we have mini module. Okay, we have one module as home, second module as about us, third module as course, fourth module as project, job, contact us, forum, blog. When I open this site, all this page are having some code on it, some code written on it, some executions written on it, so on till last. So using this lazy, what I can say, one second. Yeah, using this lazy, what I can say, when I'm going to this site as a home page, only take all the code of this home. Do not take the code of this all other options. Only execute this home thing, because whatever this visual we are seeing, the graphics we are seeing is coming from the home page. So lazy will tell me that when you're calling first time the website, only call this home. Then individually, if somebody is trying to go to project, then clicking on this project, then execute this set of code. Then if I'm going to see the contact detail, I'm clicking separately on this contact as tab, and then all code instruction is written for this contact us web page. That web page will be executed. In that short, what I can do, there are two architecture. One architecture is clicking every tab, and every time they are reloading the complete information. If I'm clicking on course, they're performing some action on job also, on this forum tab also. If I'm clicking on home, again they're performing all actions on all the tabs. So that architecture is heavy architecture. Why? Because every time you're not looking for some information, and still that page is executed internally. So when page is executed internally, they're going to take some space on your cache on RAM, and definitely they will compute this code on your server, which is CPU. So all the time this will take more time. If this is lazy, then what will happen? Only the one which I'm looking for will execute at that time. Other operations will be on hold. Then if I'm looking for this option, because this is all based on the single click. Okay, this is one rough example I have given you. There are some other example also which we can see in our concept. So real-time example I have relate that with the website, and not just this website, actually you can apply that with many website. Let's say Amazon.in. If Amazon.in use it, and they have total customer database as 200 million. Active customer, if 1% is also visiting at the same time, or 0.1% is also visiting at the same time, this is more than a lakh. If more than a lakh people visiting at the same time and running something on Amazon.in website, okay, or purchasing something, so their server load will keep increasing, decreasing. Some cap will be there to fit in based on the percentage. Now, how can we deal with this? Again, apply lazy. So if somebody is looking only for one item, only that item should be reflected and visible in front of that user. Other information should not be executed internally. So those are architectural definition, and lazy is applied with the product architecture. Okay, how this works? Let me write one operation first. Here I'll say where op1 is equal to 300, and I know this is integer. So op1 is an integer and the value is 300. Okay, now if I want to change this, okay, so changing is the second cause. As soon as you write 300 and enter, immediately what is happening? Let's read the execution of this one line. What is happening in this line? When you run this op1 and 300, so op1 is a variable, it's a reference for you, and this 300 will have some memory address. This 300 will have some memory address on JVM, because the compilation of Scala is on Java virtual machine. So op1 is a variable for us. This is in English reference for us. When we want 300, we'll call op1, and this is assigned in memory. Okay, so can I call this memory as a RAM for a while? Because current always, whenever you perform anything, it always goes to first your volatile space. After volatile, then they go to permanent, which is a disk operation. Okay, once you go to RAM, okay, it stores this volatile space, then immediately they go to CPU. Immediately they go to CPU after this memory and try to execute this 300. Now, whatever is the size of this 300, since this is integer, let me consider this is a 4 byte. So what will happen? 4 byte of this data will go to CPU. 4 byte of this data will go to CPU and occupy one CPU, some space, some percentage of CPU, and try to execute this 4 byte. And then it will give you one answer as 300, right? This will give you answer as 300. You'll get this number. So actually you're just writing this single line, but this three thing is happening in background. Now my question is, if you are writing a big number or big collection, let's say you said 1 to 1000. So all the number from 1 to 1000, 1, 2, 3, 4, 5, so on till 1000, this number will be immediately stored in a RAM first, and all this number, whatever is the size, 4 into 4 byte into 1000, you're going to get total 4000 byte. So 4000 byte of total space will be going to your CPU for execution purpose, and it will occupy some percentage based on your CPU availability based on the processor type, and they will take some X unit of time to process it, right? You see 2 second, 5 second, 10 second. So that is what is a unit of time. How much time your one CPU is taking to process that input. Okay, so unit can be in millisecond, microsecond, nanosecond, picosecond. It can be any second. This is purely based on the CPU performance or how you're working with a single core, double core, multi-core, what is your total number of core. So hopefully I'm able to make my point how this is happening internally. If I make somehow this value as lazy, if I make this lazy, then what will happen? The execution will stop. The CPU request will stop. And first thing, this lazy does not work with where. So this is in the architectural acceptance itself. I've written that definition also from the lazy architecture, and that says that lazy is not applicable with where. It's not applicable with where. The reason being why it is not working with where, because where is mutable. If it is mutable, I'm keep changing their values and redefining the values. So maybe my performance where I'm using lazy cannot be affected as similar it is affected with well, which is a concept of immutability. So lazy always works with immutable concept. Okay, not with mutable. So one thing to point here, and why it is not working if somebody asks you, because this is mutable. If this is mutable, then every time I'm changing, maybe my x is 10, maybe my x is 20, maybe my x is 30. So if this is keep changing, performance will degrade. Hence, they have discarded this concept of where to apply with lazy while creating the architecture for lazy itself. So this the architecture itself does not support their mutability. Okay, so I cannot apply. And however, if you want to check this, you can use lazy and see the error. So whatever I'm saying, okay, I said this does not work. Please check from your end also why it does not work. What sort of error this refer if you type this. So when I type this, I get lazy not allowed here. Only wells can be lazy, which means only well can be lazy. So can I try to make now well with this? When you type this, you can see total 300 is the output which assigned. So definitely this is stored in your memory. I'm not denying this is stored in a memory. But what is pending? The CPU operation has not been started. Whatever is the byte, 4 byte, 4000 byte, 4 lakh byte, this is not going to communicate to CPU. So I have stopped the communication time, as in I have stopped at the point where they go and request to CPU. I said when I will ask, then go to CPU, not immediately. And the same thing will work for all the concept. Like if I say 300 and 1 to 10, sorry, and this is range. So I can make this range. Can you see it here? 1, comma 2, comma 3. I'm not able to see because my execution step has not yet requested to CPU. CPU is still in a waiting position for this OP1. Memory is there. Now if I type, okay, when the action will start. So you can understand this two part in Spark anyway, we'll see. You can understand this two part as a transformation and action. So transformation means you're not requesting to CPU. Action means you're requesting to CPU. So this is currently, we have assigned one value. Now I'm going to operate it. I'll say OP1 and I only want to see OP1 fourth index. What is happening here? And this is the good example, I think. So 1 to 10, can I read this as a 4 byte into 10? And I'm assuming this is integer. Okay, so 4 byte into 10. Because this again, I think Ryan started. Maybe if it disconnects, okay, allow me to connect again. Currently net is there, but yeah, if 5-10 minutes will again see the same concept. If it disconnect, I will connect again in 2 to 3 minutes. So if disconnects, please wait. 4 byte into 10. I'm taking this example. Every byte size is 4 byte and total element is 10. So total size is 40 byte. If I do not use this concept of lazy, then what will happen? This 40 byte will immediately go to CPU and take 40 byte of space and give me the answer as 1, 2, 3, 4. Okay, still what I said. I said I do not want to check all the value. I only want to check this OP14. Now what will happen? This is my action. When I call this action, then this will immediately go to CPU and try to process just one element. So if it is only processing one element, this is creating total how much space they are taking to process it is 4 byte, isn't it? Because one element is 4 byte. This 4 is not a byte, okay? This is an element. So confuse that, I can change this index to 7, let's say. For this also, it will take just 1 unit of time. So every execution is taking 1 unit of time. This is what is the concept of lazy. Now, if I apply this with a file, okay? So to read a file in a Scala, we have, well, f1 is equal to source, or I think it's scala.io. This is a file handling operation. We'll see in detail. This is small case. Dot from file, and here I'll give file path. Okay, let me take a file. I'll take any X file. Let me go to desktop. So any X text file. I'll create one text file. Cat lazy.txt. Okay, and here we say, okay, this is lazy example. I'm just writing this line and Control D. So I want to read this file using my file handling operation from this cell. So here I will write that. And whenever you're reading from local file system, you have to mention file colon and file name, which is lazy.txt. Okay, let's say I give a file name which is not there. So first I will treat the file which is there, and then later which is not there. Mk string. Let me remove this file thing. Okay. Currently it is reading from local file system. This package is for local only. I was thinking this is for HDFS also, but no, this is for local only. And to read the file, what you have given the package name, scala.io.source.from file, and you are giving the path, and you're using mkstring function to see the data. This is what is my data. If I give some file name which is other file name like lazy1.txt, which is not there, we know, because our file name is lazy.txt. So we are getting error exception, that file not found exception, which means it is clearly known or visible to us that file is not present. This lazy1 file is not present in the desktop directory, hence I'm getting this exception. Now, how can you deal with this? I can say, can I make this lazy? If I make this as lazy, will it throw me error? Now this will not throw me any error because this has not computed so far. This is just referred one location for memory. If it does not mean for computation, it doesn't know whether the file is there or not. When I call this F1, then action will take a place and go to CPU and try to execute this. But can I handle this way? In background, if I check this, if I change this lazy to lazy1.txt, and now if I try to execute this, I can see it now, because first I changed in background and then I'm requesting it. So this is how it can be dealt. If you know one file is coming with some number of element, but you don't know how many file, what is the input, you can just create them using lazy. And when you see their actual data is there in your server, then you can compute them. So for reference, you can create anything with lazy. This is amazing actually. So this is your if loop and else loop. We'll see other if loop. There are total conditional expressions. If I write, there are total seven conditional expressions. Okay, which we'll see in our IntelliJ. If just if loop, so I can read this as a conditional expression. I'll repeat this concept again. If loop, if else loop, we'll be writing if else condition, we'll be writing nested if else. Nested if else means if condition, then within if again we have if else condition. Then fourth condition is if later statement. There is a fourth condition of if later statement also, multiple if else condition. Then fifth one is for loop, sixth one is while loop, and seventh one is break the condition at your requirement. So if you want to break the condition at some point, you can use this breakpoint. This is what is a conditional expressions, guys. Okay, we are currently seeing if and if else, nested if else, and other things. I will take those in IntelliJ. So this is about lazy. One more thing we'll see today, for loop. So how can I apply a for loop or a inner for loop? Okay, so for loop works like this. I can say for, or if you want to store this in any variable, you can store it. Well, f loop is equal to for, and you can say I is going from 1 to 3. I is going from 1 to 3, and println I. So we'll get this 1 to 3, right? This is like a, we are iterating them, we are traversing them. This is like a traversable. So we are traversing 1 to 3 to I and printing their value. I can use some sort of logic also. I can say 1 to 10 and give me those values which are even number. If you ask this question, that total number 1 to 10 and give me those values which are only even number. So even number works with a concept of mod. Okay, mod as. So here I can say this I is having all the value. I is equal to 1, I is equal to 2, so on till I is equal to 10. And now you said I is divided by 2. I is divided by 2 is equal to 0. Okay, so this is a modulus thing. Modulus we have modulus. I think this is known to us. How can we check any modulus? Let me take one quick example to get this point even clear. Suppose I have one 25 divided by 7. This is the numerator part, and this is the denominator part, right? So simple math, 25 by 7. Now we'll try to divide this as many time it can divide this absolute. So 7 into 3 is 21. 7 into 4 is going more than this. Okay, so I'll take always till this before 25 number, which is 3. 7 into 3 is 21. 25 minus 21 is giving me 4. So this 3 is known as a quotient. If I talk in statistical terms, this is a quotient, and in the math, this 4 is your remainder. So actually this 25 by 7 can be known as this. This is what is concept of remainder. Okay, so take 25 by 7, like if I say 95 by 10, you'll say the remainder is 5, because 10 can divide 95 9 times, which is 90, and 95 minus 90 is giving me 5 as a remainder. So that 5 is remainder. This is when your numerator is bigger than the denominator. How if this is the opposite case? How if this is this kind of case? So when it is opposite case, and you can note one line here, when your numerator is smaller than the denominator. Again, I repeat, when this numerator is smaller than the denominator, then the numerator itself is a reminder. If you're falling in this condition, then your numerator itself is a reminder. If I write in a pseudo logic code, I'll say this. Then my reminder is a numerator itself. So reminder is a 10, reminder is a 99 here. Okay. I'm one second. I just have to change this. Like, yeah. So when numerator is bigger than the denominator, we get this as our reminder. So reminder is clear now. The modulus is clear. This can be represented as 10 modulus 95. We sometimes call as mod also. 89 modulus 99 or 89 mod 99. Okay. Let's see this. So here I said all this number, if it is divided, one second, if this is divided by 2, then this is the even number, because yeah, if any value is divided by 2 and that is the completely divisible, which means there is no remainder, then I can say those values are even number. If I'm dividing some value by 2 and there are remainder not equal to 0, those are odd number, right? This is the core concept. Now I'll be repeating this for all the numbers. So 1 is 2, then second time it is I is 2, then 3, then 4. So if I divide this 1 by 2, let me write this. If I divide this 1 by 2, 2 by 2, 3 by 2, likewise I'm doing this till last element, which is 10 by 2. So 1 by 2, if I divide 1 by 2, this 1 is a numerator and this is a denominator. We have given this numerator is smaller than the denominator, then this itself is a reminder. And is this condition true for that? This condition is not true because 1 is not equal to 0. This condition is false. Similarly, if you divide 2 by 2, this is completely divisible, so reminder is 0. This is proving and fitting in the concept. This is again not fitting in the concept. So whatever is even number will fit, odd number will not fit. And after this experiment, I'll get answer as 2, 4, 6, 8, 10, which are my even number from 1 to 10. So in between 1 to 10, these are my even numbers. And 1, 3, 5, 7, 9 are my odd numbers. I can prove both. I'll see one by one so that you are clear to the concept of numerator, denominator, this modulus, because I'm going to use this modulus concept everywhere in Scala, many places. And here we'll say if I, okay, if I write that condition in this bracket, if I modulus 2 is equal to 0, then print this number. And you're getting at last unit, okay? What is that unit? You're getting the number, but at last you're getting unit which is having a common bracket, and it does not store anything. This unit means I can read this as a wide type. This unit is like a wide type, okay? Which means whenever you write any statement, especially in the for loop, and this is just a println statement. It is not storing anything, it's just printing it. Println is a function which is printing whatever operation is satisfied after this condition. So 2, 4, 6, 8, 10, this is satisfied, that's why I'm getting as answer. But this if loop has not stored anything. This if loop is empty, and that's why you're getting this unit type as this type data type as unit for this. Unit means white type, it does not contain anything. Because if you ask me, can you check F loop? I'll say, okay, there's nothing. Because F loop is unit type. Okay, so remember this point. F loop, for loop is type of unit, Why it is not storing anything? Because you are using println statement. Println statement is to just print that in the console, not actually storing anything in this loop. If you want to do that, you have another operation, and the function name you can remember, this is yield. This will yield your output and store in f loop. If I type f loop now, it has a type of integer, and it has a collection element which I'm considering as a vector. I'll take this vector separately in collections. Okay, so currently it is giving me in form of vector, and this is the output. So if you want to store it, in which application will be storing it? When you want to operate this 2 4 6 8 10 6 8 10 further. If you do not want to explore it further, want to multiply, or using some references, then you can use directly println statement. But if you're thinking I may need this output after some stage, then you have to apply this yield operation. So application wise, you'll understand when to use this at which situation. Currently, it's like we're in grammar of Scala. Now, after f loop, this is the condition. Okay, if you ask me to give me the condition for, I'm just printing it currently. Okay, for odd one, I'll say not equal to 0. This will give me odd numbers. So this is the modulus one, which is like kind of filtering my total number. Okay, that's for just one for loop. From tomorrow, we'll see multi-dimensional. Like if I want to use inner loop inside loop, and then I want to execute that. So kind of multi-dimensional concept we'll be using. Tomorrow we'll see this for loop, and there are so many things to come. We'll see one by one.